Hey everyone, here is a 3D scan of a hospital helipad in the US. It was captured with the SHARE S20 LiDAR scanner, and I'll be showing you how to turn this scan into a CAD model using BricsCAD. This scan was shared by one of this channel's viewers. His company specializes in inspecting helipads to ensure they meet safety standards. He needs to convert this scan data into CAD so he can create floor plans, elevations, and cross-sections. That way he can check the distances and angles of nearby obstructions like trees, roofs, and light poles around the landing zones. Let's take a look at how this scan was done and what improvements could be made. The S20 is his very first LiDAR scanner, and this scan is also his first attempt. My advice for beginners is to practice with the scanner until you feel confident using it before deploying it on a real project. This is where he started and finished the scan loop. At that point, he had the scanner pointed toward the low feature area, the handrail. It's better to point the scanner toward the building during initialization. That way, the software can recognize more features and close the loop more precisely. If I were doing this scan, I would start out on the road and point the scanner toward the parking building. From there, I would capture the trees and light poles along the drop-off zone, which has multi-level roof structures, and then move on to the helipads. On the helipad, since it's an open area with no obstructions, I would walk in small loops because the SHARE system uses a multi-slam algorithm. Smaller loops help improve accuracy. After that, I would walk down the ramp and return to the starting point, making sure to face the scanner in the same direction as when I began. Let's take a closer look at the scan results. The color point cloud turned out really well, sharp, clean, and detailed. Looking at the joints between the ceramic tiles, you can see they form a very sharp line. That's a clear sign of the scan precision. If the data were to shift, those lines would blur out instead. The floor paint on the helipad is really clear. I can easily trace its markings in CAD, including the positions of the floor lights. The viewer didn't walk down into the drop-off area, but I think there is still enough information here to build the model. Before you start modeling in CAD, it's crucial to level your scan data first. I'm rotating the point cloud along the Z-axis and aligning the longer side of the floor deck with the X-axis. Doing this will help you create the model faster. Looking at the cross-section along the width of the floor deck, you can see it has a slope for rainwater drainage. Because of that, this floor surface can't be used to level the scan data. So I will use the top of the wall as the reference for leveling the scans. You need to level the scan in both X and Y axis. After making the adjustment, I recheck the cross-section. Now the road is level. The floor decks sloped down on the right side for rainwater drainage. The drop-off area floor is level and the building wall is straight. When checking the floor deck cross-section along its length, it is level in this direction. Leveling the scan data is a necessary part of the reverse engineering process. If you skip this step, the model will fail. This part of the road is the lowest point in the scan data, so I move it up by 5.23 meters to align with the origin point. Here is in BricsCAD. The LiDAR scan point cloud is set to meter, so I will model everything using meter units. In BricsCAD, you can open point cloud data directly without needing any third-party software. I set the point count to 5 million for faster viewport performance. So the viewport will display 5 million points at a time, and you will still get full resolution when you crop or zoom in. First, I will model the ground, which includes the road pavement and the sidewalk. Now I have a ground plane as a solid, and I will move it down to the lowest point of the road. Now you can see that the road in front of the parking building is angled. But since the road surface is straight, I will create a triangular profile and extrude it. The sidewalk is also angled, so I will first extrude the profile up to the highest point, then create a diagonal line and use the push-pull command to cut it. The sidewalk across the road is quite faint, but I can still make out the wall line. Now I'm creating a raised ground for the garden area. Next, I will start modeling the floor deck by moving the UCS to the lowest point of the floor. Because this floor isn't level, it's angled to allow rainwater to run off toward the roadside. There are 5 fall drains along this side of the wall. Each is 4 inches in size, which is considered very small. In Thailand, more drains are needed because rainfall can reach up to 500 millimeters per hour. I'm using the manipulate command to set the floor at an angle, which is a very fast modeling method. Now I'm extracting the floor boundary to create a handrail. Some of the handrails are made from wire rope, while others are brick with a steel pipe on top. For simplicity, I will model them as a solid wall. Now I'm extruding the handrail columns. One advantage of BricsCAD is that it allows direct editing, so you can easily adjust wall positions and column height using the push-pull command. This handrail is angled, so I will use the manipulate command to create the angle in just one click. Now I'm adjusting the wall thickness to align with the point cloud. I just create a sketch over the solid face and use the push-pull command to drag the surface in or out. This part of the staircase wasn't captured by the scanner, so I will set the rise to 200 mm and going to 300 mm. Now I'm creating the ramp using the slice plane command to unblock the view and trace the angle. This raised strip over the floor looks like a walkway, but I think it's meant to prevent rainwater from reaching the handrail. This handrail on the wheelchair lamp is also angled, so I will use the manipulate command to model it. Now I'm modeling the wheelchair lamp using the sweep command. Now I'm adjusting the floor slope using the manipulate command. In fact, this command saves me a lot of time. I use it more frequently than modeling with mechanical parts. Now I'm modeling the hospital building. Not all data was captured, but it's enough to review the elevation obstructions around the landing zone. This scan data from the S20 is sharp and clean, making it easy to trace. I can work within a 2 cm tolerance. Reverse engineering a building is one of the easiest modeling tasks in CAD. It mainly relies on simple commands like extrude, push-pull, and sweep. The modeling sequence is straightforward, starting at the lowest point and build upward to the roof level. You only need to understand how to create a sketch plane using the UCS. In the future video, I might make a basic tutorial on UCS since it's the key to 3D modeling. If you can create a sketch plane anywhere in space, you can model any shape. Some viewers ask if there is a way to automatically create a sketch from a slice point cloud. BricsCAD does offer line fitting, auto trace, and a few automatic sketch generation tools, but I never use them because I spend more time trying to make those two work than simply tracing the sketch manually. And even if they did work, I would still have to spend a lot more time correcting them. For example, these two flat loops are less than half captured. How could AI or auto tracing generate the entire roof? Now all the hospital buildings are fully modeled. Okay, I move into this small box. It could be the storage room for safety equipment. There are two of them, and luckily they are identical in size. Now I'm tracing the helipad sign. I think this is an important part. One thing I noticed about the helipad floor plan is that the cross sign is asymmetrical and the rectangle frame and the signal lines are too. BricsCAD has light poles in its model library, but they don't match the one from the scan, so I modeled them from scratch. It's not hard, just 3 extrusions. I use the trees from the library. Since they are blocks, you can rescale them along the X, Y, or Z axis to match the actual tree size. This is the Airbus H130 helicopter model that I downloaded from the BricsCAD website. And here's the finished CAD model of the helipad landing zones. For an experienced CAD user or an architect, it should take no more than 3 hours to model this. The CAD file size is only 15 MB, even with the helicopter model included, compared to the 1 GB size of the point cloud. Here you can also convert the 3D model into 2D CAD drawings, including plans, elevations, and cross sections. Alright, I hope you learned something from this tutorial. Thanks you guys for watching. I'll see you in the next video.